A key to our interest in thermodynamics as chemists is the idea of thermodynamic spontaneity. And it's unfortunate that we use the term spontaneity because everyone already has an idea about what that means. And as chemists, thermodynamic spontaneity does not mean that we are prone to throwing confetti or breaking out into dance at any moment. But thermodynamic spontaneity has a very particular meaning. So in thermodynamics, we're always thinking about starting at some initial state and going to some final state. If we say that process is spontaneous, all it means is that process can actually happen. Things that are non-spontaneous are things that can never happen. And the reason this is the second law of thermodynamics. So spontaneous processes that happen, are things which increase the entropy of the universe. Now it sounds very complicated, but it's actually something that you have a lot of intuition for when you're looking at things that happen in the everyday world. So let's imagine I had a brick in my hand and I was to let go of the brick. No one would be surprised at all that the brick falls to the floor because that's a spontaneous process. So the initial state is the brick in my hand, the final state is the brick on the floor, and that happens without any problems. But I can stand with my hand over the brick for as long as I want, hoping that it will fly back up into my hand. But the reverse process will never happen. And that's because dropping the brick increases the entropy of the universe. The energy that was stored in the potential energy of the brick is converted into kinetic energy as the brick falls. And then as the brick hits the ground, that energy is dispersed in vibrations in the floor, and then vibrations out into the building, and then vibrations into the ground, and then out to the edges of the universe. I can wait as long as I want for that energy to come back and concentrate under the brick and fly up into my hand, but it will never happen. And that's because the forward reaction is spontaneous, but the reverse is not. Now, it's much more difficult to look at a chemical reaction and just say, aha, the forward is spontaneous, but the reverse is not. But thankfully, we have a way to calculate that. So we've invented this idea of free energy, which wraps up all of the entropy changes for the universe into one term. And things that are spontaneous lower the free energy, so they're things that will happen. And things that are non-spontaneous increase the free energy, and so they're things that won't. And you have intuition about this as well. So if you think about the reaction of hydrogen and oxygen to make water, at room temperature and atmospheric pressure, that reaction is spontaneous, which is why a mixture of hydrogen gas and oxygen gas is an explosive mixture. On the other hand, you can wait for a very long time for the oceans to start bubbling up in terms of turning into hydrogen and oxygen, and that will never happen because the reverse reaction is not spontaneous. So things that go forward will never go backwards. Now, I should say that thermodynamics only provides us the possibilities of what might happen. If something is spontaneous, it doesn't mean that it's fast. You might have a spontaneous reaction that takes thousands and thousands and thousands of years, and so that's not particularly spontaneous in the sort of real-world perspective. The other thing is that just because a reaction is spontaneous doesn't mean it will happen. There might be 2 or 3 other different reactions that happen instead. But thermodynamics will always tell us about the things that can never happen, those crazy backwards reactions that don't make any sense at all. So spontaneous simply means it can happen, and it allows us to eliminate the things that can never happen.